Let's turn our attention now to lesson 3. This is where we're going to bring in the system of inequalities. So that's where we're going to have our less than, our greater thans, our greater than or equal tos. Remember that when you solve a system of inequalities, you're actually looking for the overlap. So we'll keep that in mind as we're looking through these particular problems. So we're going to solve a system by graphing here. And again, got an alert. I want to make sure I'm paying attention. This is like test question number 3. And we're going to begin by solving this on the graphing system. Okay, so the first goal we need to meet is we need to make sure that we are getting these equations or these inequalities into that y equals mx plus b form. It's going to be our easiest way to be able to graph. So I'm going to take this first inequality, 2x minus y is greater than or equal to -3. I'm going to get y by itself. And to do that, I'm going to subtract 2x. If you'll remember, I don't like to write the -2x underneath the -3 because they are not like terms. So that leaves me with -y is greater than or equal to, and again, I like my x's to come first. So I put my -2x and then -3. My next step though, I've got to get this negative off the y, so I'm going to divide by -1. You'll have to remember though, when we divide by a negative and we have an inequality, we flip the inequality. That's very important there. 2x plus 3. Now, this inequality lets me know that the slope is 2 and the b, the y-intercept, is 3. That means on my graph, I'm going to start on the y-axis at 3. I'm going to use my slope 2, which is up 2 over 1. I almost said it backwards there. Then I am up 2 over 1 here, up 2 over 1 there. Now, you need to ask yourself, is this a solid or a dashed line? In this case, it is a solid line, and the reason is because we've got that equal to underneath it. So we are going to draw this as a solid line. I want to make sure I'm lining them up really good. And I'm going to draw a solid line through those points. Now, the y is less than. So when it is less than, we tend to remember that it is below, and I'm grabbing some colors here if you hear my noise here. It is below. Well, that means we go to the y-axis where the y-intercept is, and we shade below. So we're going to shade this section. When I taught this in brick and mortar, all of my students loved the day because I would be like, tell them a few days in advance, bring your colors, we're coloring in math class. And everybody would have a good time because there's just something very calming about coloring. I know it's childish, but try it, okay? Try focusing in for just a little while to color and you'll be just like relaxing and all kinds of stuff. That's why they sell adult coloring books. All right, let's look at the next one. Then we've got to graph y is greater than or equal to -1/2 x plus 1. Now this one, the work's already done for us, so we can easily see that my slope is -1/2 and my b, or my y-intercept, is 1. So this means I go on my y-axis to 1, put my dot for my y-intercept. Now my slope being -1/2, that means I'm going down 1, right 2. Down 1, right 2. All right, now think about it. Is it a solid or a dashed line? Well, it looks like you have an equal to underneath there. So it looks like we're going to be drawing this as a solid line. So we'll do that. I'm going to try to line these points up really There we go. Now remember on this one, we had y is greater than. So that means we're going to the y-axis and we are shading above. So we're going to the y-intercept on the y-axis, we're shading above. Now I've chosen Christmas colors today, so those are going to kind of clash maybe a little bit with the red and the green. Yeah, you can get creative, do blue and red, and you'll get a nice purple color over here where the overlap is. Now here's the beauty of this. Every point that's in the overlap section is the solution. So what I tell students is once you've graphed them both and you see clearly where the overlap is, take a third color and just darker color that one in so that the overlap stands out a little bit better. If you do just the two colors and you don't bring in the third color, sometimes you're going to get it where they just fade and you can't really tell, especially if you're using matte pencils and you're coloring very lightly. So very, very important there. All right, so I'm hoping that helps you with your linear systems. Have some fun with it. You know, a lot of times we skip over the coloring part and we're like, oh, that's just, I don't have to do that. Remember, it's very therapeutic. So take your time and see what you can come up with. Okay, so let's focus then on my last one, which is to solve a linear absolute value system. Love this one. I didn't put a grid on here, but I could have because it is going to be one that we graph. So if you'll bear with me, I'm just going to draw myself a little graph here. It's not going to be perfect, and that's okay. You can say it's okay to not be perfect. Yeah, it totally is okay to not be perfect on this one, but I do want us to see what's going on. And I say it's okay to not be perfect, and here I am using a straight edge to draw my line. So that's okay. Remember what each of these look like, okay? I know that y equals a number is a horizontal line. And so that means that I'm going to go up here on the y-axis. I'm just going to make some marks here. I'm going to draw a horizontal line at y equals 3. Ask yourself, is it going to be a solid line or a dashed line? It is going to be a solid line. So let's draw a solid line at y equals 3 here. And then we can see that it is y is less than or equal to 3. So that means that we will be shading below the y-intercept. So we're going to be shading below this line. So take a minute to color those in. There's some people who do designs and they do dashes or they color the section in there. Yeah. There's something I just love about the coloring. All right, there we go. Okay, next let's do the y is greater than or equal to the absolute value of x minus 1. I want you to remember that the absolute value graph makes a V, not a round, because a parabola is totally different, but a V, very sharp corner there. And the V normally is at 0, 0, but with x minus 1, it's actually going to shift it over 1. So we're going to have our V here. A corner of our V is going to be there. And beautiful on each side of my V is that my slope is 1. Okay, now decide for yourself, is this going to be a solid or a dashed line? I think you're catching on, right? That it is going to be a solid line here. So I'm going to draw my V on both sides. We're not perfect, so my lines aren't running like 100% through these dots. Okay, and then we are shading above, right? Because it's greater than. So I'm going to choose a color here. Oh, let's see, I'll do a green. And I'm going to do above the y-intercept, which is here, so it's above. So I'm hoping you can see that really nice overlap. And remember, take that third color then and darken that overlap section. There we go. And that's your solution. Remember, every point in this shaded section is a solution to the system. So we could easily pick out some points in here, like 1, 1, and it would be true in both of the inequalities. So I hope that helps with our system of inequalities here.